So now we're going to move on to exponents. After today's lesson, you should be able to convert numbers from exponential form to standard form, and then convert numbers from standard form to exponential form, simplify expressions with exponents, and identify parts of an exponential expression. Alright, so your vocabulary. The first word you have is exponent. And an exponent is when a number is in the exponential form. It's the number that indicates how many times the base is used as a factor. Right, so in this case, it's going to be that tiny number at the top of the larger number. So this right here is your exponent. And then your base. So in this case, we have base in multiple different vocabulary terms. The base of an exponent is when the number is in exponential form, it's the number that's being multiplied. It's the factor. So in this case, your base would be 3. And then power. So we like to say, this would be like 3 to the second power. 2 isn't the power. 2 is the exponent. The power is that answer, that solution that you get when you finish in exponential form. So if I take 2 to the second power, 4 would be the power. So 4 is a power of 2. 8 is a power of 2. It's those answers that you get that are the powers. Right, and from your exponents, you can get what we call a perfect square. And a perfect square is the product when multiplying a number by itself, or what we call taking a number to the second power. So perfect squares are numbers like 1, 4, 9, 16, 25, so on and so forth. So it's the answer to those second power or squared numbers. And then here, to get a perfect square, you have to square a number. So a number raised to the second power is what we call being squared. Right, so like 2 to the second power, so 2 is being squared. And then when you have cubed, cubed is when a number is taken to the third power. And then a perfect cube is that solution that you get, or the product when multiplying a number by itself 3 times. So if I have 5 cubed, okay, so 5 is being cubed, and then the perfect cube is 125. Now the reason they're called squares and cubes is because if you think about a square, squares have to be the same length on both sides. So if I have 2 and 2, to find their area, it would be 2 times 2, which you're going to learn we call 2 squared. If you take a perfect cube, so a 3-dimensional shape, it has to have the same height, length, and depth. So in that case, if it was 2, 2, and 2, we would have 2 times 2 times 2, which you're going to see is 2 to the third power, or 2 cubed, which is 8. That means there would be 8 small cubes inside of the large cube, if the cube was 2 by 2 by 2. Alright, so first we're going to use an exponent to write each expression. So the first thing you need to do is you need to find the base. Okay, the base again is the number that is being multiplied. It's the factor. So in this case, the base is 3. The next thing we're going to find is we're going to find the exponent. The exponent is what we're going to put up at the top of that number. So if we have this, the exponent is right here. Okay, and we find the exponent by counting the number of times the base is being multiplied. So how many times do we see this 3? 1, 2, 3, 4, 5. So the exponent in this case is 5. So then here, your base is going to be that large number. So this is your base. Make sure you label them. The base is 3. And then your exponent is the little number on top, and that exponent is going to be 5. Alright, so we really want to make sure that we know that this is the base and this is the exponent, because if you make a mistake and you put the exponent where the base is supposed to be and vice versa, it changes entirely what that problem looks like. So like if I had accidentally put 5 and then 3. This would have been 5 to the third power, and these two things are not equal to one another. A big mistake that students also make is when we actually pull this apart. So you really want to make sure you're taking your time with this. As easy as it looks, it's very easy to make mistakes too. Alright, so if you want to, you can go ahead and pause and try this one on your own, and then come back and check your work. Otherwise, you can work through it with me. So again, we're going to find the base, and the base is what's being multiplied, so it's the factor, so it's 4/5. So we can do this with fractions, and then we have to find the exponent, and we're going to count the number of times the base is being multiplied, so 1, 2, 3, 4. So multiplied. Okay, so then the exponent in this case is 4, because it's being multiplied 4 times. So my exponent is 4, and my base is 4/5. Now with this, I have to make sure to put it in parentheses, because if I don't, it looks like only the 4 is being multiplied by itself 4 times. So if it looks like this, it looks like these two pieces go together. If I put the parentheses there, it shows me that this 4 goes with the 4/5, not just the 4. Alright, so now it's your turn. You're going to take these expressions and you're going to write them in exponential form. I want you to pause, and when you come back, we'll check your answers. So here you should have a base of 4 and an exponent of 3. Here you would have 6, and your exponent could be 1, or you could just leave it as 6. Here you would have 1/8, and it should be in parentheses, and it should be taken to the second power, so squared. So here you have 5, and your exponent should have been 6. Alright, so now we're going to go in the reverse, and we're actually going to find the value of a power. So we're going to find out how much these expressions are worth. What do they give us? One of the things that you need to know is that anytime you have an exponent of 0, that number is going to be equal to 1. And we'll talk a little bit more about why that works in class. Right, so remember, the exponent indicates how many times to use the base as a factor. So it's telling us how many times it should be multiplied. So we need to identify the base and the exponent. The base is what's going to be multiplied, and the exponent is how many times to multiply it. So the base in this case is the 10. The exponent is 4, so that tells us that I'm going to do 10 times itself 4 times. So 10 times 10 times 10 times 10. Now the nice thing is that with multiplication of tens, I know that I have to just add zeros. So this would be 1 with 4 zeros, so that would be 10,000. So 10 to the 4th power is equal to 10,000. So 10,000 is a power of 10. Alright, now let's take a look at this one. Now we have a decimal. So the base is still 0 and 4/10, and the exponent is 3. So that means I'm going to multiply 0 and 4/10 by itself 3 times. And when I do that, so I know 4 times 4 is 16, and I have to move the decimal twice, so I get 0 and 16/100 times 0 and 4/10. And if I'm not sure, I can always move it over here and do the math. So I have 0 and 16/100 times 0 and 4/10. Remember, I don't have to line up the decimals because of our rules with multiplication. So 6 times 4 is 24. Carry the 2. 1 times 4 is 4. Plus 2 is 6. And I know all of these are just going to give me zeros, so I'm not going to do the second row of zeros. I have 1, 2, 3 numbers behind the decimal, so my decimal has to move 1, 2, 3 places to the left. So in this case, 4/10 to the 3rd power, or 4/10 cubed, is 0 and 64 thousandths. Again, it's just showing you what your multiplication problem is. It's just a matter of making sure you go slowly and that you remember that this does not mean 0 and 4/10 times 3. That is not correct. All right, so here I know that my base is a fraction and it is 3/5, and my exponent is 0. So here's that special situation where my exponent is 0, so I know that automatically this answer is 1. I don't even have to do any math, I just know my answer is 1. So it's kind of nice whenever you see that exponent of 0, because you know that you just have to write down a 1 and you're all set. Alright, here I have 2/3 squared, so I have 2/3 as my base and the exponent is 2. So remember, that means I'm doing 2 times 3, or 2 over 3 times 2 over 3. It's just multiplying fractions, which we're already really good at, so I get 4/9. So 2/3 squared is 4/9. Alright, so now it's your turn. I want you to give these a shot. You're going to go ahead and pause and try them, and when you come back, we'll check your answers. So here I have 3 to the 4th power, so that means 3 times 3 times 3. So 3 times 3 times 3 times 3. So I get 3 times 3 is 9. Bring down what I didn't use. 9 times 3 is 27. 27 times 3 is 81, so you should have gotten 81. Now, 1 to the 9th power does mean 1 times 1 times 1, and that's going to be 9 times. But we also have to think 1 times anything, or 1 times 1 is always going to be 1. So no matter what this exponent is, this answer is always going to be 1 because my base is 1. 2/5 to the 3rd power means 2/5 times 2/5 times 2/5. And when I do this, I get 4/20 times 2/5, and then I get 8/40. And we're just going to leave it as 8/40. You guys do not have to simplify it. And then here I have 12 squared, which is 12 times 12, which I know is 144. It's really good to practice your squares, because the quicker you know them, the faster and easier it makes your math. Alright, so the last thing we're going to do is we are actually going to try these as word problems. Alright, so we have this problem here where when Dana's school closes, a phone tree is used to contact each student's family. The secretary calls 3 families, then each family calls another 3 families, and so on and so on. So how many families will be notified on the 6th round of calls? So what this means is, so how many families, oops, that's supposed to be my highlighter, how many families will be notified on the 6th round of calls? So it's important to note that she calls 3 families and they call 3 families, and that I'm looking for the 6th round. So if you want a visual of this, because I think that actually helps us more. So the secretary starts out by calling 3 families. Then each of those 3 families calls another 3 families. So on round 1, 3 families are called. On round 2, 9 families are called. And then each of these people call 3 families. It's a lot of 3s. So it's 3, 6, 9, 12, 15, 18, 21, 24, 27. So now that's 27 families. Well, if you notice, this is like 3, and this is 3 times 3 times 3, and this is 3 times 3 times 3 times 3. Well, each time, so this is 3 to the 1st, and this is 3 to the 2nd. Okay, and this is 3 to the 3rd. So the next one is probably going to be 3 to the 4th, and we'll get 81. So if we want the 6th round of calls, what I can do is I can take that 3 and put it to the 6th power, and it should tell me how many families I called, because that's what's happening each time. Each round is the power, and that tells you how many families were called. So I know 3 to the 4th power is 81. So I'm just going to start with that. So if I did 3 to the 4th is 81, then I know that I have 81 times 3 times 3. I have 2 more 3s because I'm doing 6. So 81 times 3 is, oh, I'm running out of space. 81 times 3 is 243. Times 3, 3 times 3 is 9. 4 times 3 is 12. Carry the 1, so 729. So 729 families were called on that 6th round of calls. All right, and we'll continue to practice with these, but I wanted to give you an introduction of what those look like and where you would use this in real life. So the last thing that you need to do is you need to try your guided practice problems. I'm going to make this a little smaller, so just in case you forgot your notes, you can copy down these problems and do them on the sheet of paper that you are writing your work on right now. All right, so you're going to go ahead and fill this in. And as always, if you have any questions, please be sure to email me or write them down so we can go over them in class.